discuss, sir.
1-6, solving systems of equations. Here we go. First thing, definition, system of equations. Two or more equations with the same variables. So these will now go from having one equation like we did at the very beginning of the year to where you're solving two equations essentially at the same time. So main thing with this is to make sure like everything else stays true. You don't forget to distribute wrong, or you don't forget to distribute your negatives to the second part. You understand what you're doing, where things go, stuff like that. There's multiple different ways to solve systems of equations. All right, there's actually four that the book talks about. We're going to mainly focus on two. I'm going to quickly hit on the third one. The fourth way we're not even going to talk about because it's kind of a waste of time, pointless kind of deal. Okay. You guys have done this before. I know you have, but it's probably been a while, so I'll probably need some refreshing and coming back stuff. Okay. Everybody good definition? Yes. Okay, the first slide you don't really even need to write down, okay? I'm just going to do it real quick for you because you will never have one like this, so it's not super important that you know how to do it this way. But here we have two lines. Okay, everybody see that? We have two lines. 2y minus 1 equals negative 1, or 2x minus y equals negative 1 rather. 2y plus 5x equals negative 16. So what I'm going to do real quick is put these in slope-intercept form. So y equals 2x plus 1 for that one. And the second one is y equals, let me think here, negative 5 halves f. Negative 5 halves x minus 8. Is that right? We'll try it. Yeah. Okay, and then I'm going to go graph it real fast. So we start at 1, move up to right 1, down to left 1, and the line looks like that, not perfectly drawn to scale. The other one, negative 8, which would be down here or so. Move down 5 or up 5, left 2, so right there. Let's make that red so we know. And then we draw a line like that. Okay. Now, the reason why I'm graphing this one is because I want you guys to understand what's going on behind the scenes with whenever we get into these problems. Okay. Whenever we say we're going to solve, we're going to find the answers. We're going to find what the system of equations, what the solution to it is. And what that is for us is where the two lines that were given intersect. All right, so they intersect right there, which is the coordinate negative 2, negative 3. Okay, so that's what you're looking for. You're looking for where you're looking for the point where these two lines intersect, where these two lines cross. Let me make that look a little better. Let's go this one like that. Boom, right there is where they cross. That's all I want. And that's what your solution is. So, main thing I want you guys to take away from this is that your answers are ordered pairs. Alright? Anything you find, when you find the x equals, when you find the y equals, they're ordered pairs. You need to write them as such. Second thing, we'll come back to it whenever we get to the examples I'm thinking of. Remember what's going on graphically, behind the scenes. Alright? Your solution is where two lines intersect, where they cross at. Okay? It's a kind of higher order level question. We'll get there, okay? Any questions on that? Okay, next. First main method we're going to use is a wonderful thing called substitution. Okay, and substitution is a more methodical process. It's very much same process, repetitive over and over and over again, versus the other method. Substitution has practical uses later on in this course, so you have to know how to use it. You can't get away with elimination all the time. Okay, because a lot of people like elimination over substitution, which I do too when it's applicable, but sometimes you have to substitute. So it's important to know both. All right, your steps to substitute are, number 1, solve one equation for one variable. Okay? Solve one equation for one variable. I'm going to put a side note on number 1. You don't have to solve for y. Okay? It doesn't have to be y. Sometimes you can solve for x. Okay? You guys it's the way I see it, you guys get this and writing in slope-intercept form and graphing crisscrossed. When you graph, you have to solve for y. Here you do not. You can solve for x or a or b, whatever. It doesn't matter. Okay? You can solve for whichever one is easier for you. Okay? That's step 1. Step 2. Substitute that resulting expression into the other equation, the equation you haven't touched yet, and replace the variable, then solve the equation. It's a really wordy step. We'll get to it when we start doing them, okay? We'll explain it a little more. Step 3, substitute to solve for the other variable. At the end of step 2, you'll have a number you can go plug back in. So that's what that's talking about. All right, number 1. Solve a system by substitution. Make sure you read directions on what I want you to solve by, because whatever I ask you to is what I expect to see, okay? First one, 5x minus 3y equals 23. And then your second equation is 2x plus y equals 7. All right, so step 1 is to solve one equation for one variable. So you can pick either one of these two equations, and you can solve them for either variable you want to. There's always going to be a better one to pick, though. Okay? And for this first example, I want to take the second equation. And I'm going to solve for y. Okay, I want to get y by itself, which means I need to subtract what? If I want to get y by itself, I need to subtract 2x. So you get y equals negative 2x plus 7. Okay. That's into step 1. Step 2, take that equation, what y equals, which is negative 2x plus 7, and substitute it into the variable of the other equation, the one you haven't touched yet. Okay, so now for the next step, you're going to write 5x minus 3, but instead of writing y, you write what y equals. Let me use the green, which is negative 2x plus 7 from right there. Okay, makes sense? Don't forget to finish off that equation, make it equal to 23. Okay, from there, you go through the motions to solve that equation, right? You have a single equation with one variable in it. You guys know how to do that. Your next step is distribute. So you get 5x plus 6x minus 21. Okay, don't forget about this negative going to the second term. All right, so minus 21 equals 23. Your next step is to what? 6 and 5x combine like terms. So you get 11x minus 21 equals 23. What's next? (11x minus 21). Not subtract. Add 21. There you go. Add 21. So 11x equals 44. Divide by 11, so you get x to equal 4. Now, once you have x equals 4, you need to find y. Okay, we got x. Now we need to go find y. So you can go to either here or here with plugging it in. You could also go, and I recommend this, to this one. All right, this one makes it easier. Do the third one. So y equals -2 times 4 plus 7. So we get y equals -8 plus 7, which gives us y equals -1. And then your last step, make sure you write them as an ordered pair. So 4, -1. X first, y second. Okay. Here's how I pick. All right. Here's the easiest way. The easiest way to pick is this. If you have one that's got a variable that's all by itself, like how the top one has an x all by itself, you solve for that one. Okay. You do some things to get that one by itself. Okay. Now I'm going to make one up and show you later, just a little bit, to show you if you don't have one by itself. Okay. Now, so for this one, you add 7y over, so you get x equals 7y plus 11. Okay. Now that goes in for this x in the second equation. Okay. So you get 5 parentheses 7y plus 11 plus 4y equals -23. Very important to make sure you have all your signs right, bring them along from the original and different things like that. Otherwise your whole problem goes kaboom. And then after that, it's the same steps as we just did, okay? And that's pretty much how they always go. You solve, you distribute, so 35y plus 55 plus 4y equals -23. You got like terms to combine almost every time. Should be every time. So 39y plus 55 equals -23. You subtract 55 over. So you get 39y equals a negative, what, 78? Is that right? Then divide by 39. So y equals -2. So there you got 1. Now you can take that -2 and plug it in to that y. So then x equals 7 times -2 plus 11. So x equals -14 plus 11, so x equals -3. And then write them. Order pair them up, -3, -2. Instead of the top one, let's say the top one instead is 4x plus 2y equals 18, let's say. And you still have to solve it by substitution. What do you do now? Which one should you solve for? Anybody know? You don't have one by itself, which isn't ideal. It's going to be the top equation. All right, and you want this one. You want to solve for y. Okay, and here's why. Whenever that shakes out, you subtract 4x over. You get 2y equals -4x plus 18, and then you divide it all by 2. And then look how it all ends up being nice numbers. So y equals negative 2x plus 9. Okay, and that's as far as I'm going with this one. I'm not going to work the whole way. But sometimes you'll see one like this. Your book will do it to you on this homework assignment. I won't do it to you too much on a quiz or a test, but the book will sometimes. So if you get to one like this, just look for the smallest number and use that. Okay? Use the smallest number, and then make sure, the other part of that, make sure they're all divisible by that number. Okay, so like 2, 4, 18, they're all divisible by 2. That's what you want to use. If you go over here, you got 5, 4, and negative 23. None of those numbers are divisible by any of them, so if you would try to do this one, you would definitely 100% end up with fractions, which I know you guys don't want. Okay, so if you see one where you don't have a variable by itself, like I said, the book will do it to you more than I will. Aim for the smallest one. Okay, whichever has the divisible. All right. Typically they'll be nice. They'll be even, or they'll be multiples of 3. All right. Questions on? That's the only 2 substitutions I got. Everybody good? Next up, elimination. Now, where substitution is much more methodical, the process, repeated process over and over again, elimination is much more open-ended, is a good way to put it, I guess. It's much more, you can do it however you want to, but you still have to understand the concept of what you're trying to do. Okay, you can't just do, whatever you want. You have to understand what you're doing, but at the same time, you have a lot of different options of how you can proceed with these problems. It's much more open-ended, which means that you have to understand that much more what you are trying to accomplish. Because I could do it different than you guys. And all y'all could do it different from all y'all. And we still all end up with the same answer. Okay? So with elimination, while it is easier for the most part, you really have to understand what you're trying to get done, because you could do it multiple ways. There's not one set way to do it, so you have to understand what it is you are trying to accomplish. Mainly what it is you want to get the last few words in this definition is the main ones in the first part of the definition. You want to get opposite terms. Okay? Opposite terms, for example, are 2x and negative 2x. Okay? 4y and negative 4y. 18x and negative 18x. Same sign, or same numbers, different signs. Those are opposite terms. Sometimes they will be given to you. Sometimes you'll have to make it happen. Okay, and making it happen is where step 1 comes in. Multiply one or both equations by a number to result in 2 equations that contain opposite terms. Okay, opposite terms is the key here. Step 2, add the equations together, eliminating the variable that has the opposite terms. Right? Because what's 4x plus a negative 4x? 4x plus negative 4x gives you 0. Right? 0, which is good. That's what you want to have happen. That's why it's called elimination. You want to eliminate one variable. And then solve that equation. Take that number back in, solve the other equation. Like I said, this process is much more open-ended than what substitution is. Okay, what I see and what you guys see and what, 7th hour sees and what my honors kids see and what my accelerated kids see, it can be all totally different on how to do it, but we can all get to the same answer. Okay, so you really have to understand the process and what it is you're trying to accomplish. All right, so number 1 with this elimination. We got 5x plus 3y equals negative 19. And we got 8x plus 3y equals negative 25. Okay, now, very few of you had me for Algebra 1, so I don't know how you all were taught how to do this, so I'm going to teach you the way I recommend. If you like it, cool. If you don't, that's cool too. This one is technically set up ready for you to go, but I don't like it. Okay? You have like terms, but you don't have opposite terms. See the plus 3y's here and here? There's a method where you can do this as it is. I don't like it, so I want opposite terms. So to make one of these terms opposite, I'm going to take the top equation and multiply everything by a -1. And then I'm going to write that down here. So 5x times -1 to go -5x. 3y times -1 to go -3y. -19 times -1 to go with positive 19. You multiply everything, all three parts. Okay? From there, your focus should be on those two equations. And you just add those up. So 8x plus -5x gives you 3x. 3y plus a -3y gives you what? Not y. What y? What's 3 minus 3? 0. What's 0 times y? 0. So it's 0. Okay? Which is the key. That's how this works. Okay? Those have to be opposite terms, so they fall out. Equals -25 plus 19, -6. Okay, so as you can see, way easier to get to that first number, but you have to understand conceptually what you're trying to do up here. Okay? That's the hard part. So now you go divide by 3. Which gives you x equals -2. Now that you have x, you can plug it into one of these equations and find y. So I'm going to take the top equation. I almost always take the top equation just because it's on top. So you go 5 times -2 plus 3y equals -19. Now I plugged it into x because it says x equals -2, so that's why it goes into x. If this was y equals -2, it would go in for y and you would solve for x. Okay, so you just replace it with whichever variable it is. So you found x is -2, that's why it went here. Make sense? And then from there you have an equation that you can solve. So 5 times -2 gives you -10 plus 3y equals -19. Add 10 to both equations, or both sides rather. Get 3y equals -9. Divide by 3. Y equals -3. And then write it as an ordered pair. Alright, next one. 3x plus 8y equals 30. 4x minus 3y equals -1. Okay, now it looks somewhat similar to the last one. Please don't fall into this trap. This is 3x, this is 3y. Are these like terms? No, they're not. Savannah was quick with that answer. No, they're not. Don't think you can just flip-flop these and make it work. Doesn't happen that way. Okay? Now, with this one, this is probably one of the more complicated ones you guys are going to do. In the fact that you have to multiply both equations. Okay, so if it doesn't work out to where you already have them as opposite terms, or you have the same number but just different signs, then you got to do a little pre-work. Okay, and the pre-work to that is kind of, I don't want to say daunting, but you have to understand what you're trying to get done. All right, it's kind of what I'm keep harping about with this part. You have to understand what you are trying to do. You want these equations to have one of the variables in both equations be the same number but opposite signs. Okay, that's the main goal. Now, to accomplish this, you can multiply the one equation by one number and the second equation by another number. So that way it happens. Okay? So what I look for is this. I look for my two terms. I look at my two x's, I look at my two y's. And I see if their signs are already different. Okay? In this one, the x's are both positive, but the y's are opposite. See that? One's plus, one's minus. So I look at that and I go, bingo, that's what I'm going for. Okay? That's what I'm going for. Once you establish that, you need to figure out what number you need to multiply up to. So basically, I'm asking you, what's the first number that 8 and 3 multiply into that have common factor? Okay. What's the first number that 8 and 3 have in common when you multiply? Start going up your factors. 8 times 1 is 8. Very good. 8 times 2 is 16. What's 8 times 3? 24, right? Okay. And then go up your 3's. 3 times 1, 2, 3, 4, 5, 6, 7. I'll speed you. We'll walk you there. What's 3 times 8? 24. So you need to multiply both these equations to get them to be 24. Okay? So, you look at the first one. It's 3x plus 8y equals 30. What do you have to multiply that one by to make 8y be 24y? 3. But the catch is you can't just do it to the one term, you got to do it to all of them. Okay? So you can't just do it to what you need to, you got to do it to everything. Alright? So that one's going to give you, when you do that, 9x plus 24y equals 90. The bottom equation you're going to multiply by an 8. Because that's what's going to make that y term become negative 24. And that's what you need. Okay, so we got 32x then minus 24y equals negative 8. Then you add those up. So 9x plus 32x gives you how many x's? 41, good. 24y minus 24y gives you how many y's? 0. That's what you need to have happen. Okay? Equals 90 minus 8. 82. Divide by 41. And x equals 2. Now that you have that, you take the 2. You can go into either one of these equations. It doesn't matter. I typically go into the top one just by habit, just because it's on top, and I don't know. It's on top and it wins, I guess. I don't know. So 3 times 2 plus 8y equals 30. 36, there we go. So 6 plus 8y equals 30. Y equals 3. So your order pair is 2, 3. Okay, we're not fully done with this lesson. All right, we got 2 more to talk about. We'll do that tomorrow. And that's these 2 here. We don't have enough time because we only got like 4 minutes left. So we'll talk about these 2 tomorrow. You're still going to have a worksheet tomorrow, okay? I still want you guys to do this homework tonight, okay? Page 48, 46 through 60 even. Since we didn't get to the last slide, we need to cross 2 out of your homework. It looks like 2. So you need to do 46 through 60 even. And for now, whoops, not skip. There we go. Skip numbers 50. It's actually 50 and 60. Okay. So skip 50 and 60.